While you rest, there are people awake. There always are. In every time zone, in every season, in every kind of weather that still allows even a fragment of clear sky. There are people at their telescopes and their computers and their spectroscopes, working through the small hours of the night, collecting light from objects that most of the world will never think about. Astronomy is a night profession. The sky that its practitioners study is only properly visible when the sun has set and the atmosphere has cooled and the thermal turbulence that distorts starlight has calmed. Even with space telescopes that can observe regardless of the time of day, the culture of ground-based astronomy is a night culture. Late dinners eaten quickly before heading to the dome. The peculiar exhaustion of someone who is doing exactly what they love, but doing it in defiance of their own circadian rhythm. When the announcement about 3I/Atlas was made, hundreds of these night workers immediately redirected their efforts. Telescope time is precious. It is rationed by committees, allocated based on the scientific merit of proposed observations, competed for by researchers from institutions around the world. To secure time on one of the major telescopes, the twin Keck observatories at the summit of Mauna Kea, the very large telescope on Cerro Paranal, the Gemini Observatory. You submit a proposal months in advance. It is reviewed by your peers. It is scored and ranked and fitted into an oversubscribed schedule. But there are provisions for the unexpected. For targets of opportunity, objects that appear suddenly and require immediate observation before the scientific window closes. 3I/Atlas qualified immediately. Alerts went out. Existing programs were interrupted, their observers generously yielding hard-won telescope time for something more urgent. Observation schedules were restructured overnight, and the data began to arrive. There is a particular quality to the excitement of early data from an unprecedented object. The signal is noisy. The uncertainties are large. Every feature might be real or might be an artifact. Every pattern might be meaningful or might be random fluctuation. You are looking at something that has never been looked at before through instruments designed for objects nothing like this, trying to extract reliable information from a signal that is barely above the noise. But somewhere in that noisy, uncertain data is truth. Real information about a real object from a real other star system. And the work, painstaking, unglamorous, demanding in its attention to detail and its tolerance for ambiguity, is the work of extracting that truth, separating signal from noise, building up, observation by observation, a picture that is reliable enough to trust. The scientists who stayed awake for 3I/Atlas were carrying a particular kind of privilege, the privilege of knowing something that human being had ever known before, of holding a fact about the universe in their hands, however tentative, however uncertain, that had never been held before. They shared it, as scientists do, through preprints posted online at 3 in the morning, through breathless calls to colleagues in other time zones, through papers submitted to journals while the data were still coming in. We didn't have to stay awake. We just had to listen, and here you are, listening. 3I/Atlas is not a world, not in the way Earth is a world, a planet large enough for gravity to have pulled it into a sphere, to hold a substantial atmosphere, to sustain the geological processes of plate tectonics and volcanism and erosion and deposition that continuously reshape the surface. Not in the way Mars is a world, or Europa, or Titan. It is too small, too irregular. Its gravity, far weaker than Earth's, is insufficient to crush mountains flat, to maintain an atmosphere, to hold liquid water even if the temperature permitted it. But it was, once, part of something larger, or part of the material that tried to become something larger and didn't quite make it. In every planetary system, the process of formation is violent and chaotic. From a disk of gas and dust surrounding a newborn star, gravity begins to accumulate material with remarkable speed. Dust grains collide and stick. Small rocks form. Larger bodies sweep through the disk, their gravity attracting more material with each orbit. In a relatively short time, astronomically speaking, a few million years, the disk is depleted. Most of its mass is concentrated in a small number of larger bodies, the planets. Most of it, but not all. The gravitational dynamics of a forming planetary system are complex and sensitive to initial conditions. Small bodies in resonance with large ones can be flung into highly elliptical orbits or ejected entirely from the system. The gravitational influence of giant planets, once those giants have grown large enough to dominate their orbital neighborhoods, can reach across the disk, destabilizing populations of small bodies and sending them on long, looping trajectories. Some of these trajectories lead inward, toward the star. We see the results as meteor showers, as short-period comets, as the cratering record preserved on the surfaces of old worlds. Others lead outward, past the orbit of the outermost planet, the system's outskirts, into the Oort cloud equivalent of whatever system produced 3I/Atlas, and some lead further still into interstellar space. 3I/Atlas is one of those outward flung fragments, a piece of chemistry assembled in a protoplanetary disk around a star we may never identify, ejected from its home system at some point in a history we cannot reconstruct, and set on a trajectory that brought it, after hundreds of millions of years, to our solar neighborhood. It carries no message from its origin, no label, no record, no deliberate information, but it carries information nonetheless, in its composition, in the ratio of water ice to carbon dioxide, in the abundance and types of organic molecules, in the mineralogy of its silicate dust, is encoded the chemistry of another planetary system, the temperature and pressure conditions of the disk where it formed, the abundance of heavy elements in the molecular cloud that made its parent star, perhaps even hints of the dynamical history of the system, whether there were giant planets nearby, whether the disk was volatile rich or volatile poor. Scientists call this planetary archaeology, reading the history of worlds from the fragments they leave behind. 3I/Atlas is a fragment from a world we will never visit. But tonight, it is here, and we can read it, even if only a little, even if only for a brief, extraordinary window. Feel the weight of your body sinking deeper. Every breath carries you little further from wakefulness. The thoughts are becoming less insistent, less form. Let them go whenever they come. Return gently to the breath, to the story, to the dark. Over every careful spectral measurement, every comparison to reference databases, every late-night discussion between astronomers trying to explain the anomalous features in its spectrum. Nobody states it plainly in the scientific papers. The language of peer-reviewed astronomy is cautious, hedged, precise. Claims are qualified. Uncertainties are quantified. Alternative explanations are listed and evaluated. But the question is there. Are we alone? Not in the dramatic science fiction sense. Not, is there a spacecraft approaching Earth? Not, we about to receive a message? Not any of the scenarios that have populated our storytelling for a century. The question is more subtle and in some ways more profound. In the chemistry of this object, in the molecules it carries from a star system we will never visit, is there any evidence that the universe is doing somewhere else what it did here? Building complexity, building organic molecules, moving step by incremental step along the chemical pathway that leads from simple atoms to amino acids to proteins to, eventually, something that can ask questions about itself. The honest scientific answer is, we don't know. The current data does not allow us to address this question directly. The spectral resolution of our instruments, applied to a fast-moving, outgassing comet at a distance of tens of millions of kilometers, is insufficient to detect specific, complex biological molecules, even if they were present in abundance. The signal from any biologically interesting chemistry would be lost in the noise. And even if we could detect complex organics, that alone would not be evidence of life. Complex organic molecules form abundantly in space through purely chemical processes. They've been found in meteorites, in cometary material, in interstellar molecular clouds. The building blocks of biology are not unique to biology. They are products of ordinary chemistry under the right conditions. But the question of life elsewhere is not a question that science has answered, or is close to answering, or may answer in our lifetimes. What we know is this: life emerged on Earth. It emerged relatively quickly, within perhaps 1 billion years of the planet's formation, under conditions that we are still working to fully understand. It emerged from chemistry, from the same molecules that are found in comets and meteorites and interstellar clouds. What we do not know is whether that emergence was inevitable, whether given the right conditions, life always arises, or whether it was vanishingly improbable, a cosmic accident unlikely to have been repeated in the history of the observable universe. The answer to that question changes everything. It changes what it means to be alive, what it means to be conscious, what we should think about our place in the cosmos. It is not a small question. 3I/Atlas does not answer it, but it is a piece of data, a real physical piece of another star system, available for study, carrying information we've never had access to before. Every piece of data matters. Every measurement adds a constraint. Every constraint narrows the space of possibilities. Science works slowly. The answer to the question of life elsewhere will not come from 3I/Atlas alone. It will come from the accumulation of evidence across decades and centuries. From better telescopes and better spectrometers and better theoretical models. From missions to the moons of our own outer solar system, where liquid water oceans might harbor something alive right now. But 3I/Atlas is part of that accumulation. A small piece, a precious piece. Here, now, in the dark, the question floats above you like a star. Are we alone? We don't know, but we are asking. And that asking is, in itself, one of the most remarkable things the universe has ever done. 3I/Atlas is leaving. That is the nature of all interstellar visitors. They arrive carrying the momentum of their ejection from some distant planetary system, follow a hyperbolic arc around the sun, a curve that brings them close for a brief astronomical moment, and then carries them away forever and depart, never to return. The sun's gravity bends their path. It slows them slightly on the inbound leg, then accelerates them again as they fall toward perihelion, their closest approach. After perihelion, the gravitational slingshot flings them outward with energy borrowed from the sun's own vast mass. They leave faster than they arrived. The departure of 3I/Atlas will take years in human terms. It will spend months in the inner solar system, during which it will be at its most active, its most visible, its most scientifically productive. Then it will move outward through the realm of the giant planets, each one exerting a tiny gravitational influence, adding a small nudge to the object's trajectory. By the time it crosses the heliopause, the boundary where the solar wind meets the interstellar medium, roughly 120 astronomical units from the sun, it will be receding at a velocity slightly different from its arrival velocity. The solar system will have left its mark on 3I/Atlas atlas, just as the object will have left its mark on our understanding. And then, once again, silence. Once again, the dark. The same profound, deep, timeless dark through which the object has moved for so long. In 100,000 years, it will be farther from the sun than any human-made spacecraft. In 1,000,000 years, it will be beyond the reach of any mission we could conceivably design with technology developed in the next few centuries. In 1,000,000,000 years, it may approach another star, and if that star has planets, and if one of those planets harbors something that looks up at the sky and wonders, they might, with sufficiently sensitive instruments, detect the tiny anomaly in their sky that is 3I/atlas. They will not know it came from here. They will not know that a small, brief, enormously curious species on a rocky planet around a yellow star spent months training their instruments on it, arguing about its composition, writing papers about its anomalous spectral features, posting late-night threads on academic forums, trying to explain its behavior. They will not know about any of this. But perhaps, and this is, admittedly, a very human kind of imagining, perhaps they will wonder. Perhaps they will ask, as we ask, what this object is and where it came from, and what it might carry from its unknown origin. And in that wondering, if it ever happened, there would be a thread, a connection across the void, not made of light or matter or any known physical force, made of the same impulse, the impulse to look, to ask, to understand, that makes us human. That impulse is, as far as we know, rare in the universe. It might be unique, or it might be everywhere, expressed in forms we haven't yet imagined, directed at questions we haven't yet thought to ask. We don't know, but we keep looking, and the universe, for its part, keeps providing things to look at. Rest now. Let the muscles of your face relax. Let your jaw drop slightly. Let your hands open. You are deeply, beautifully comfortable. The world is doing fine without your attention for these hours. The stars are watching over you. The universe continues its enormous business. And somewhere in the dark, moving at 30 kilometers per second through perfect silence. An ancient visitor from another star is making its way through our neighborhood. It is almost gone now, but it was here, and we noticed. From space, Earth is luminous. It glows with a blue that is unique in our solar system. The blue of deep oceans, of scattered atmosphere, of water in all its forms. From orbit, you can see the white swirl of weather systems, the long curves of coastlines, the dark mass of continents, green and brown and ochre. At night, the lights of cities trace the edges of human settlement in veins of amber electricity, visible from hundreds of kilometers up. From the outer solar system, it is invisible, lost in the brightness of the sun. From the distance of the nearest star, it is undetectable with current technology. From the distance that 3I/Atlas has traveled, it is less than a mathematical possibility, and yet it is home. The word carries so much: warmth, familiarity, belonging. The memory of specific places and specific light, the particular quality of afternoon sun through a particular window, the smell of a particular garden after rain, the sound of a particular street at a particular hour, the accumulated, unrepeatable sensory history of a life lived in one place. Earth is home in the largest possible sense, not just your home or the home of any particular culture or species, the home of life, the place where 3.8 billion years ago something began to happen that had never happened before anywhere in our solar system, and may have never happened anywhere within many light years of here. Chemistry organized itself into biology, and biology, over the following billions of years of evolution, produced something that could look up at the sky and wonder where the light comes from, that could build instruments to collect more light, that could understand the physics and chemistry of stars and planets and comets, that could calculate the trajectory of an object arriving from interstellar space and trace it back with appropriate uncertainty to a general direction of origin, that could lie in the dark and listen to a story about an ancient visitor from another star. You are the product of 3.8 billion years of life on Earth. You breathe oxygen released by the photosynthesis of 2 billion years of plant life. You carry in your cells the accumulated innovations of every organism that survived long enough to reproduce in the history of life on this planet. You are, in the most literal sense, made of the universe. And for a brief, remarkable window, a few decades in the context of a life, an eye blink in the context of the cosmos, you are aware of it. You are the universe, turned briefly to face itself, looking out at the dark, asking questions, telling stories, and right now, resting. The questions can wait. The universe will still be there when you wake up. 3I/Atlas will still be moving through the darkness on its long way to wherever it is going. The stars will still be burning, each one a furnace producing light that takes years or centuries or millennia to reach you. The Milky Way will still be turning slowly on a time scale that makes the whole of human history look like a single heartbeat. All of it will still be there. But right now, none of it requires anything from you. Right now, you can simply be here, in the warmth, in the dark, in the quiet, and now we come back, slowly, the way morning light returns, not all at once, but gradually, the darkness thinning by degrees, the world becoming present again in layers. We leave the ancient visitor to its journey. We leave the cold silence of the outer solar system. We leave the faint blue glow of Neptune and the pale rings of Uranus and the swirling storms of Saturn and the roiling surface of Jupiter. We pass Mars and its rust-red deserts and its towering extinct volcanoes. We pass the moon, gray and ancient and patient, and we come back to Earth, to this blue world, this unlikely world, this world that managed to produce oceans and continents and weather and life and, eventually, a species curious enough to look up at the sky and ask what everything is. We come back to a night sky, to darkness that is full of stars even when the clouds hide them, to the air that moves gently around you, the surface beneath you, the weight of a body at rest. You have been somewhere remarkable tonight. You have followed an object from another star Through hundreds of millions of years of solitary travel, you have watched it warm in the light of our sun and begin to exhale the frozen chemistry of its birth. You have stood in imagination above its dark, irregular surface and felt the faint warmth of a star 150 million kilometers away. You have watched the scientists who stayed awake to study it, collecting their noisy, precious data in the small hours of the night. You have held the question that all of this raises, are we alone? And felt it dissolve gently into sleep. There is nothing more to do now. Your body is heavy and warm and perfectly still. Your breathing is slow and even. Your thoughts are becoming less like words and more like colors, shapes, impressions. The soft kind of thinking that happens at the border of sleep. Not quite dreams yet, but close. The universe is very large, and you are very small, and somehow, impossibly, both of those facts are comforting. The vastness is not frightening. It is freeing. There is so much space, so much time, so much that exists beyond the edges of any individual life and any individual worry. The universe does not need anything from you tonight. It only needs you to rest. Drift now. Let the story release you. The visitor has passed. The telescopes continue their patient watch. The scientists will be back at their instruments tomorrow night, and the sky will be there, as it always is, full of light that left its source years or centuries or millennia ago, and has been traveling ever since, through perfect silence and perfect dark, on its way to your eyes. Let your eyes be closed now. Let the light wait until morning. The night is long and the dark is comfortable, and the stars are very, very far away. Sleep well. Sleep deeply. You are home. There is a particular kind of vertigo that comes from thinking about deep time, not the vertigo of heights, which is physical and immediate, and rooted in the reasonable biological response to the possibility of falling. This is a different sensation, a cognitive kind. The faint dizziness that comes from trying to hold a number so large that the mind cannot actually represent it, can only gesture at it, approximate it, trace its outline without ever grasping its full weight. try to feel the length of 1 billion years, not calculated, not converted into seconds or multiples of a human lifespan. Just feel it. Let the number sit in your body and see what it does. Most people find it produces a kind of softening, a loosening of the ordinary grip of things. The concerns of a day, a week, or even a lifetime begin to seem lighter, not meaningless. That is a misunderstanding of the perspective that deep time offers. Not small, just lighter, more bearable, more clearly situated within something so much larger that the proportion is immediately, viscerally obvious. This is one of the gifts that astronomy offers to anyone willing to receive it. Not escape, not the erasure of difficulty, but context. The context of a universe that has been doing extraordinary things for 13.8 billion years and will continue doing so for an incomprehensibly longer future. Your worries are real. Your joys are real. Your relationships and your work and the texture of your days are real, and they matter in the way that things matter to the conscious beings who experience them. But they are also held within something vast, something that has existed since before the earth was formed, something that will continue long after the last star burns out. And somehow, improbably, in the middle of all of that, you are here, awake for a few decades, aware, curious, looking up at a sky that has been there for your entire species and will be there long after your species is a footnote in deep time. That is not cause for sadness. That is cause for wonder. Let the wonder settle into you now, like warmth, like the specific, comfortable warmth of a bed on a cold night, seeping into the muscles, softening the thoughts, carrying you gently toward rest. The 1 billion years is out there. You are in here, and right now, that is exactly right. Let us imagine, briefly, that we are not the only ones watching. This is, of course, speculation. Beautiful, scientifically informed speculation. But speculation nonetheless. We have no confirmed evidence of any intelligence beyond Earth. The search has been ongoing for decades. Radio telescopes scanning for artificial signals, optical instruments looking for laser pulses, newer instruments attuned to a wider range of possible signatures. So far, silence. But the silence is not evidence of absence. It is simply silence. The Milky Way contains at minimum 200 billion stars, a significant fraction, perhaps half, host planets. Of those planets, some orbit in regions where liquid water could exist on their surfaces. Of those, some will have been stable enough, for long enough, for chemistry to organize itself into biology. Even if the probability of life around any given star is very small, the number of stars is so very large that the expected number of inhabited worlds in our galaxy alone is probably not zero. So let us imagine somewhere around a star we have not named, on a world we have never seen, something is looking up at its sky. Its sky might be dim and ruddy, lit by a small red dwarf star burning at a fraction of our sun's luminosity. The habitable zone would be close, perhaps close enough for the world to be tidally locked, one face always in daylight, one always in permanent night, a narrow band of perpetual twilight in between, where the temperature permits liquid water, and perhaps life, or perhaps two suns trace their dance across the sky, a binary system with double shadows and double sunsets, seasons governed by two gravitational influences instead of one. Whatever the sky, the physics is the same. Gravity works the same way. Light travels at the same speed. The spectral lines of hydrogen and carbon and oxygen are identical. The universe speaks one language, and any intelligence it produces will eventually learn to read the same sky. And perhaps, somewhere, sometime, something like us was looking at something like a moving point of light, an interloper, and asking, "What are you? Where did you come from? Are we alone?" It is possible that 3I/Atlas was once studied by other eyes, other instruments, built by other minds, on worlds orbiting stars we have not yet catalogued, in times before our species existed. We will probably never know, but the possibility is real, and it is, quietly, one of the most extraordinary thoughts available to a human being lying in the dark on a still night. Breathe in that thought. Let it be large, and then let it go. Let everything go. Your body knows how to sleep. It has been doing so since long before you could think about it. You only need to stop interfering. Let the muscles soften. Let the breath find its own rhythm. Let the night do what nights are for. Science is often presented as a process of accumulating answers. In one sense, this is accurate. The scientific method has produced more reliable knowledge about the physical world than all other methods combined. We know what stars are made of. We know how old the universe is. We know the size of an atom and the distance to the nearest galaxy, and the mechanism by which DNA encodes the information of life. But science is also, and perhaps more fundamentally, a process of generating better questions. Before Galileo turned his telescope on Jupiter, nobody knew that other worlds had moons. Before spectroscopy, the composition of stars was considered unknowable. Every major discovery in the history of science has generated more questions than it answered. 3I/Atlas is no exception. Its anomalous spectral features have generated questions that will take years or decades to resolve. Its trajectory has deepened interest in the population of interstellar objects throughout the galaxy. Its chemical composition, or rather, the parts of it we do not yet understand, has opened new avenues of inquiry in astrochemistry and planetary science. We do not know what those anomalous features mean. We do not know where it came from. We do not know whether the complex organics it carries reflect an unusual formation environment, the effects of cosmic ray processing, or something we have not yet thought to consider. We do not know, and that not knowing is not a failure. It is the most honest possible state of any mind confronting something genuinely new. It is the beginning of all scientific progress. It is the door through which understanding eventually enters. There is a particular kind of pleasure in genuine not knowing. When you are in the presence of something truly new and you understand that you do not yet understand it, that is a gift. That is the mind in its best possible relationship with reality. Open, humble, curious, and deeply, genuinely interested in what the answer answer might be. Children experience this constantly. The world is full of not knowing, and they meet it most of the time with delight. Every new object, every new sound, every new situation is an opportunity to update their model of how things work. Adults learn to close that openness with the accumulated weight of pattern recognition and prior experience. It is efficient. It is usually correct, but it costs something. 3i/Atlas does not allow that closure. Nobody has seen this before. Nobody has a prior experience to match against. The only honest response is full attention, genuine curiosity, the willingness to sit with a question and not rush it toward an answer it is not yet ready to give. That is a skill worth practicing. And the night, with its slowness and its darkness and its distance from the demands of the day, is a good time to practice it. You do not need to know how tomorrow will feel. You do not need to resolve anything tonight. You only need to be here in the dark, breathing slowly, with the question floating gently above you like a star. The answer will come in its own time. For now,